Let's see here if we can. Yesterday during the lesson, it actually came up what today's lesson is going to be about. We talked about how sometimes there are numbers that only one in itself will work as a factor pair. We call those numbers prime numbers. You guys came up with a few of them yesterday randomly. That just kind of happened as our lesson progressed. Every other number is called a composite number. That means more than one in itself will go into it. So we need to know our math facts today. That's certainly going to help. And I need to every whole number that's greater than 1 is either prime or it's composite. A prime number has exactly two factors, 1 and itself. And a composite number has more than those two factors, Sarah. Is the number 3 a prime or a composite number? Sam says it's because only 1 times itself. Only 1 times 3 give us 3. Good work. Why would 8 be considered a composite number? Put your pencil and your eraser down for the last time. Will?
Because more than 1 equals it.
More than 1 times 8. Can you give me some more examples other than 1 times 8?
2 times 4.
Good. Because in addition to the 1 and itself, 2 and 4, just like Will said. How about 27? Is it prime or composite, Darius? Okay, tell me why. Like what? Other than 1 times 27? You think so? If you actually use those divisibility rules that we taped into your journal, you would be able to tell. First of all, we could start with the 2's. Say it again. 3 times something. And how did you know that? Because you added up the digits and you got 9, and you know 3 will go into 9. Thank you, Darius. What if that would have been an even number? Then do we know right away?
2.
Yeah, we know that it's got to be composite. There's only one even number that's not composite. Do you know which one it is? 0 isn't a whole number. 2, because only 1 times 2 gives us 2. Aiden? Yeah. Does anybody know 3 times what? Darius helped us out. He knew it's 3 times something. Aaron? 3 times 9. Good work. Okay. We know it's not divisible by 2, but we did know it was divisible by 3. Good work. So let's try a little bit of guided practice here. 71. Whew. Well, is it even? No. Is it divisible by 3? No. Is it divisible by 4? No. How about 5? If it's divisible by 5, it has to end in a 5 or a 0. How about 6? Can't be 6 because for 6 it needs to be 2's and 3's, right? What do you think? Dathan, what kind of a number is 71? It is a prime number. Good work. It is kind of like 17. 63. Let's go through our list. Is it even?
Yeah, no.
No, not even.
It's what's
The other word besides prime starts with a C.
composite?
It is a composite number. Can you tell us why?
Because 63 times 1 and 9 times 7.
That's right, 9 times 7. But other than 9 times 7, which is a basic fact, if you would have went through the list of divisibility rules, what's one you would have noticed right away would be divisible by this? What? 3. Because if you add up the 6 and the 3, you get 9. 3 goes into 9. Let's do this one. Alexis? Prime or composite? And why do you think so? What's the very first thing you should always ask yourself? Always, first. Is it even? Is that number even, Alexis? Yeah? Okay, if it's even, what number goes into it for sure? 2. So that means more than just 1 times 86. So what kind of a number is it, prime or composite? A what? You meant composite. Okay. I don't even care what the other numbers are. As long as we see it's even, we know it can't be prime. $97. Sam W? Tell me what are some other factors other than 1 times 97? It's not even, right? Nope, it's not even. Will 3 go into it? Will 4 go into it? 5? 6? It is prime. Okay, next, I'm going to teach you guys a trick. I'm going to teach you how to do what we call prime factorization. That's a lot of words, right? What we're going to do is, in short form, we're going to learn how to make factor trees. Have you ever made a factor tree? Well, let's start with an easy number like 20. Okay? All you need to do to start is make a branch off the 20. What 2 factors give us 20? Sam, you first. 5 and 4, or it could have been 10 times 2. It doesn't matter which factor you start with, as long as they equal 20. So we're going to go with Sam's. 4 times 5. Okay? Are either of those 2 numbers prime? Which one's prime? Dathan? The 5 is prime. We're going to circle it. That means we can't make any branches off of it. It's as low as it'll go. Only 1 times 5 gives us 5. How about this number? Is that prime? No. So that means we can make a branch off of it. What are the factors of 4? We can never put 1s on our tree. Aaron? 2 times 2. Are either of those prime? Some are saying yes, some are saying no. Yes, only 1 times 2 gives us 2. That's it. So that means we can't go any lower. So our answer is, we start with the smallest one. 2 times 2 times 5 gives us 20. Another way to write this is as an exponent. 2 to the 2nd power times 5. Remember how we did exponents? If there are 2 repeated, we can use an exponent. Let's do another one of these. Let's do let's do 42. 42. Can you give me any factor pair that'll give you 42? Natasha? 6 and 7. Are either of those prime?
Yes.
Which one, America?
7.
The 7. So we're done with it. We can't do anything else. 6 is not prime. Give me the 2 factors of 6. Aaron? 2 times 3. I don't care if you put a 2 here and a 3 here, or a 3 here and a 2 here. It doesn't matter. Are either of those prime?
Yes.
Which one? Both of them are prime. We're done. The smallest number is 2. So I start with that. 2 times 3 times 7. I would not accept the answer 7 times 3 times 2. We have to start small and work our way up. Nothing is repeated, so we don't need to put any exponents in there. Let's try another one. This one you can do on your iPad. Open it up. And let's do this factor tree together. Do this together. Give me 2 factors of 32. Any 2 factors. Somebody help me out. Will. Come on, come on. You can do it. You can do it. 8 times 4. All right. Are either of these numbers prime? Okay. Which one's prime? So only 1 times itself. Oh, never mind. Okay. Dathan? Neither one are prime, right? So we can put branches off of both of these. Which one do you want to help me with? 8. The 8? 2 times 4 gives you 8. Are either of those numbers prime? Which one? 2. Not 4, right? So we can branch off the 4. What's going to branch off the 4? Eileen, are you going to follow with us today, or are you just going to? Thank you. Both prime. We know 2's are prime, and we can go back up and do the same thing here. Now, there's one way to write this for an answer. We could write it 2 times 2 times 2 times 2 times 2. Or, how could we write it as an exponent? Aaron? 2 to the 5th power. Much shorter, much quicker, much cooler. Any questions on that one? I think we have time to do another one here before my time runs out. Let's do, okay, let's do 36. Okay, Eileen, don't worry about the 3 and the 6. Just get started on your problem. Darius is itching to share how he got it. What'd you get, Darius? How'd you start it out? 4 and 9. Okay, that'll work. I noticed that Eileen did 6 and 6. That would have been fine too. So would have 2 and 18. So would have 3 and 12. Any of those would be okay because you're going to get the same answer at the end. All right, so Darius, are either of those prime? Nope, neither one. So we can make branches off them both. What are the factors of 4? How about 9? Huh. Are any of those prime? Yes. All of them are prime. So we're done, except to write the answer, which is what? Right? Yes. Is there any easier way to write that, Sarah?
You can make the 0 to the 2nd power and then 3 to the 2nd power.
Absolutely. That would have been just as good. Same thing. But what we can't do is start with our bigger numbers and move down. We always have to start with our smaller numbers and work our way up. Okay? Good work.